Okay, so we got notes 7.2, we got horizontal and vertical reflections. And remember, reflections just means a mirror. And still, it will stay congruent from your pre-image, that's not how you spell that, image to your image, right? So remember, this is like your regular letter, and this has got your prime notation. So what's going to be the most important part of today is this line of reflection, okay? So this is the actual line that we will reflect across. And what's really important, and like a good way of checking your work as well, is that the points are equal distance from that line of reflection on each side, right? If you are, if this is your mirror, right? If you're this far away from your mirror, then you will be like that same amount away from your mirror, okay? So that's what that's saying, is like however far away you are from your line, it's going to be the same on both sides. So notice that my graph here is loose. And that is because I am going to show you two different methods, right, of like checking your work. So first things first, you will need a colored pencil of some kind today. And it says we are going to reflect across the x-axis. So that means that the x-axis is my line of reflection, right, that LOR. So what I'm going to do is I'm going to color that line of reflection, and I am going to expect that from you today. Okay, and so now what we will do is we will plot the points so that they are equal distance from that line of reflection. So this letter E, if it is 1 away from the line of reflection, and then the other side, it needs to be 1 away. So my E prime is also 1 away. If my G is 1 away from the line of reflection, then on the other side, it is also the 1 away from that line of reflection. So I got G prime here. And then F. F is 1, 2, 3, 4 away. So on the other side, it must be 1, 2, 3, 4 away. So there's my F prime. And notice everything looks like it is still the same distance from each other, right? It's just flipped over. And a good way to check your work is what I'm going to do is I'm actually going to kind of fold on my line of reflection here real quick. And then I'm going to fold it on the other side, right? I'm just folding that line of reflection. And when you kind of like take this, I don't know if you guys can see it super well, but you can actually see that they line up so good that it only looks like that one side is there, right? When you like look in the light, it looks like there's just one thing there. If you want to check it out, but that's a good way of checking to make sure you reflected correctly. I mean, the main thing is making sure you find your line of reflection, but that is a good way to check your work, right? Again, but it all depends on if you draw your line of reflection properly. So next what we're going to do is we are going to talk about just some observations that we can come up with. So in the pre-image, right, the original problem here, we have these points. I pre-wrote them because I don't want this video to be too long. And in the image, we are going to write out the points that we got because I didn't know what they were going to be. So we have E prime, its x value is -4, -1. F prime, say F prime here, is 0 and -4. And then G prime x and y value, G is -1, -1. So when we take a look at, how it changed, take a moment, right? Pause the video, maybe see if you can figure out what the change is, and then see if you can answer it from or if you get the same answer as me. So when we reflect over the x-axis, right, because that was our This was our LOR. The only thing that changed, so we went from -4 to 1, -4 to -1. We went from 0 to 4, and then 0 to -4. And for G, we have -1, 1, and then it went from -1 to -1. So when we reflected over the x-axis, the y value, changed signs. So that kind of makes sense because we're just going over the x-axis, right? The x value isn't going to change if I go up or down. But when you go up or down, right, y values change. So that is kind of fun to think about. So maybe on a piece of scratch paper, right, we could ask ourselves this question. What would happen if you reflect over the y-axis, right? So I'm interested if you would, or I would be so very grateful if you could maybe on a piece of scratch paper, since I'm not here, put that in the class bin so I can see your answers and, you know, kind of make sure you're doing your work. Okay, so that's what happens with axes, right? There's like a special thing that can kind of happen with when you reflect over either the x-axis and even the y-axis, right? And you're going to figure that out when you get to your spice packet. So in this next part, though, we have this other graph, and again, it's not glued down, and it says we are going to reflect over x equals 1. Okay, so this is different, right? This is not an x-axis. Well, we see that we have x, right? So that means I'm using this axis here somehow. And it says at x equals 1. So that's right here. So the line that we draw that can only go through x equals 1 is straight up and down, right? So this time it's different, right? Even though it says x, like it's going up and down my line of reflection, right? We've done this before. So now what I can do is the same type of deal, right? We have to see 1, 2, 3. F is 1, 2, 3 away. So that means on the other side it needs to be 1, 2, 3 away. So this is where F prime goes. G is 1, 2 away. So on the other side it's 1, 2 away. So we got G prime. E prime is 1, 2, 3, 4 away. So on the other side it's 1, 2, 3, 4 away. And that's E prime. And now I have a reflection, right? Because it looks kind of opposite. That's how it kind of works. And then I can check my work by kind of folding on this line. And you know, it's important to make sure you draw your line of reflection correctly. So I fold it this way so I can get the line right. And then I fold this way to see if I can see it. And I don't have a light. But if I like hold this up to the light, you can kind of see, you only see the one outline happening on both sides. So that means I reflected it properly because they are just mirror images of each other. So that's a good way of like checking your work. So that's why your packet's a little bit thicker, so you have the ability to fold if you want. You can always check with each other as well. Okay, now with these ones, there really isn't a special pattern, right? So I'm gonna even write that. Or even when y equals a number, okay? Now remember, if we had like y equals 3, right? If we had y equals 3, then, or I'm sorry, let's say -3. If y equals -3, then y equals -3 is right here. So the line of reflection would go across, okay? I'm sure I have a very old YouTube video kind of going through this stuff, but that's the other notes. Work on your spicy packet. In the first one, it is once again you're starting off with writing the rule. So you need to figure out, right, in this one, how far away or where would be the line of reflection, right? So in this case, I would kind of fold to like see if it would work kind of deal, or even just kind of like draw a sketchy line and see how like when I draw this out, this C is 1, 2 away, and then the C prime is 1, 2 away. So that would be their line of reflection. So when I write it out in my rule, I would say, okay, it reflects over, and let's see, this is going through -2 on the x-axis. So we have x equals -2. And then let's see this one, right? We have C and C prime. Oh, same letter. That's fun. We have C and C prime again. So we're trying to find which way it reflects. Now, this time it's kind of going this way. So my line of reflection, right, I'm going to sketch it out first. And let's see if it makes sense. This is 1 away, and then this is 1 away. So that works out. Now in this case, we're going through a y value, right? We're going through a y value, and we're going through at 3. So this reflects over y equals 3. Okay, so that's how these bell peppers work. You know, do as many as you need until you are confident. You can fold your paper to see if it works and look into the light, but there you go. All right. And then, you know, the special rules come across with the axes for when we get to 3 jalapenos. And then, you know, ghost pepper is getting smarter, stronger, faster. Same with Reaper. Okay? All right. Have a good day.